Hello everyone. In this video, we will discuss about molar mass. So molar mass is pretty much you have known all about it. It's just a fancy term for your atomic mass. So let me rephrase this. So molar mass is basically the mass of 1 mole of an element. So what does this mean? What is 1 mole? 1 mole equals to 6.02 into 10 to the power 23 atoms, right? Atoms of that element. So if I line up all those elements, so all those atoms, and how many are? 6.02 into 10 to the power 23, and put on my scale, whatever my weight would be, that's my molar mass. Do you guys get it? So if I line up all of my atoms, like 6.02 into 10 to the power 23, which is 1 mole, all of the atoms, put them in a weighing balance and measure the weight, and whatever the number that pop up in that display, that's gonna be my molar mass. So by default, what we have figured out is molar mass is basically the same number as our atomic mass number, but expressed in the gram. So molar mass is the atomic mass expressed in grams. So for example, let's say we talk about carbon. Carbon's atomic number is 6, right? So if you look at the periodic table, carbon's has atomic number is 6, right? You'll see the mass, atomic mass of carbon is gonna written either in the bottom or somewhere on the top. It doesn't matter. You will see the 12.01. That's our atomic mass, right? Weighted average atomic mass, so AMU. So if I ask what is the molar mass of carbon, so for this one, the molar mass of carbon is 12.01. It's the exact same number, but it's written in gram. And what does this mean? This means 1 mole of carbon atom. So if I line up all 6.02 into 10 to the power 23 particles of carbon atoms and put them in a balance, they're gonna weigh how much? 12.01 gram. So this is our equality term for this conversion fact. So this is our equality term. So what would be our conversion factor then? So this is critical, guys. You will be using this a lot for the rest of the semester and for rest of your chemistry career. So the conversion factor would be per each 1 mole, it weighs 12.01 gram, or 12.01 grams equals 1 mole of carbon atom, right? So that is our conversion factor. So let me ask you a question. 60 grams of 60.05 gram of carbon contains dash moles of carbon atom. So I'm asking how many moles of carbon atom present in 60.5 grams. So that's given. So your given is 60.05 gram, and you want to find out how many moles present. So what you have to do is multiply conversion factor, and which one would that be? The one where mole is on top. So it's per each 1 mole, it is 12.01 gram. So gram cancel, and if you do the math, then it's gonna come across as 5 moles. So I'm not worried about the sig fig, but if we have to worry about sig fig for now, let's not worry about sig fig for now. I'm just doing the simple conceptual math for now. Okay, so that's 5 moles, right? So let's do another problem like this. So what is the mass of let's say 5 moles of lithium? So you'll see a questions like this: what is the mass of lithium? 5 moles of lithium. So first thing you want to do is write the equality term. So what is the equality term? So you have to find out the molar mass of lithium. So find the molar mass. And where would you find the molar mass of lithium? From the periodic table. From periodic table. So just look at the periodic table, and what number you will get. So you will get for lithium, the number is 6.941 gram. So the molar mass is per each 1 mole, it is 6.941 gram. So what would be the conversion factor? Per each 1 mole, it is 6.941 gram, or 6.941 gram of lithium contains 1 mole. And what's the questions we are given? So given was 5 moles, which is the given. That's our given. So we were given 5 moles. And you want to find out how many grams is that, right? So which conversion factor has gram on top? This one. So it's 6.941 grams per each 1 mole. So mole cancel, and if you multiply, that's gonna be 5 0 515 540 257 4 5 34. Okay, 34.705 grams. That's it, guys. That's the answer. All right, so let's do one last problem. So you can create a lot of problems. So just put any random number, grams, any random number, 10 gram, 12 gram, 30 grams of, so put random number here. So this is how you should make your questions. Put random number here, element, random element, contains mole of atoms. That's the question, guys. So you should just do it yourself. So put any random number there. So what's your favorite number between 1 to 100? What's your favorite number? Let's say I will say 52. Yeah, why not? 52 gram of any random element. So let's say put sodium. So 52 gram of sodium contains how many moles of atom? So this is our question. So that's what you have to find. So step 1, molar mass of sodium. And what is the molar mass of sodium? Hopefully, let me find my periodic table. It's 22.99. Yep, it is 22.9. I'm just making sure. 22. 22.99. So when we write the molar mass, either you write as AMU or grams per mole. That's the right way to write grams per mole. So that's 22.99 grams per mole. So what's the equality term? For each 1 mole, it is 22.99 gram. The conversion factor would be 1 mole divided by 22.99 gram, or 22.99 gram per 1 mole. And how much we have? 52 gram. And you want to find out how many moles that is. So the conversion factor that has moles on top is this. And then plug in the calculator and find your answers. Sounds good? Alright, so I'm gonna stop here and then we're gonna jump into molecular mass from now onwards.